Hello, and welcome back to another set of math speedruns with me, Vince. Today is day 5 of the speedruns, and we will be covering chapter 2.1. And this is quite a short chapter, so that's good, but it's also very important that you understand it. So let's jump right into it. So chapter 2 is all about functions, and first we need to understand what a function is. So first we have to go a bit bigger and we have to say what a relation is. So a relation is like a set of ordered pairs, not x minus y, x and y, so that, x is part of a set, y is part of a set, and they are not empty sets. So, I guess a better way to think about a relation is if you're graphing it. A relation can really be anything. It can be like a squiggle. It can be like normal curve. It can be like a straight line, or it can be like another straight line. It can be anything that just has an x coordinate corresponding to a y coordinate. Now, a function has a very big distinction, and that distinction is that a function, the x values of a function must have a unique y value. And what do I mean by that? What this means is that for a function, every x value, say this is x, must only map to one y value. So they can map to the same y values, say this is y, but they can map to the same y values, but a function should never have more than one y value per x value. That's a big no-no. So a relation is a function if the function acts on all the elements of the domain and it is well-defined. So well-defined means that it is only one y value for each x value. Yeah, that's pretty much it. And so, talking a bit more about functions, the range of x values, or the set of x values, say in our very simple function here, we have x and y. The range of x values the set of x values, in this case 1, 2, and 3, is called the domain. It's D. And the set of y values is called the range of the function. So this is important because some functions are only defined for a certain domain and some functions are only defined for a certain range. Okay, I think that was pretty much it for functions, so let's get into some questions. So, where are our questions? Okay. There are not that many questions right now. So, our first question is to simply determine which of the following relations are functions. For those that are functions, state the domain and range. For those that are not functions, state the reason why. Okay, so our first relation is going to be 1, 2, 2, 3, 3, 4, and 4, 0. And it's pretty simple that this is a function. This pretty much is a function. For every x value, you have a unique y value. That's how you tell if it's a function. The domain of this function will be when x is less than or equal to 1, or actually, in this case, it doesn't look that continuous, so I guess it might be better to say x is part of the set 1, 2, 3, and 4, and y is part of the set 2, 3, 4, and 0. I think we can just say that. So let's just check if that's correct. And yeah, oh, that's a skills check. Nope. Yeah, so we are correct. That is a function indeed. So now we're gonna go to the next one, and the next one is 2, -2, 2, -1, 2, 0, and 2, 1. And this is clearly not a function because we only have one x value and there are multiple y values that it corresponds to. This looks like on the x side we have 2, and on the y side we have -2, -1, 0, and 1, and it's mapping to all of these. So this is clearly not a function. Okay, let's move on to the next one. And that would be, oh, it's a diagram, okay. So we have A having 1, 2, 3, 4, and 5, and B having 2, 4, 6, 8, 10. So 3 and 4 both map to 10, 5 maps to 2, 1 maps to 2, and 2 maps to 4. And this is a function because for each value in A, it's mapping to 1 and only one value of B. And so this is completely fine, even though, you know, some values are the same. It's like saying on a y, on this kind of graph, if these 2 points are the same y value, it's still a function because they have different x values, and no x value has more than one y value. Okay. Now, moving on to the next one, we have 2, 5, and -3 is going to -5 and 12. And the thing is, this isn't a function. And so remember, there are 2 conditions of function. Sorry, a relation needs to satisfy to be a function. The first is all of the x values map to y value. Well, actually no, the only condition is all of the x values map to 1 and only one y value. And in this case, this 5 here isn't being mapped to anything, so it is clearly not a function. Okay, so we need to next determine which of the following graphs represent functions. So I'm going to draw the x and our y axes, and our first graph is something that looks like this. And we can, okay, the way to check if a graph is a function is we use something called the vertical line test. And it means that if we draw a vertical line anywhere on the graph, it should only be able to pass through one and exactly one point. And in this case, well, if we draw a vertical line over here, it's going to pass through more than one point. It's going to actually pass through all the points of the function. This wasn't a pretty good graph to show what I actually mean by the vertical line test, so I'm going to demonstrate it first. So say we have a graph of an actual function, like so. If we draw a vertical line anywhere on it, there should only be one and only one intersection. If I draw it here, it will be over here. If I draw it maybe here, it's going to be over here. And so if we graph something that is not a function, so like let's say this curve over here. Now if we draw a vertical line here, you can see there is more than one intersection over here. and so therefore it cannot be a function. Don't worry about drawing a vertical line over an empty space because functions have predefined domains and ranges, so if it doesn't hit anything, it should be okay. Okay, now on to our next graph. We need to determine whether this is a function. And as like before, we can use the vertical line test. As you can see, if we draw a vertical line through here, then we have more than one intersection, which means this x value corresponds to more than one y value, and therefore it is not a function. Okay, next. We have, what in the world? Oh, we have a set of points. And the thing is, this thing doesn't look like a curve, right? It doesn't look like a function, but actually it is a function. Because as long as there are no 2 points on the same vertical line, it is a function. It may seem really weird to you, but that's the truth. So as long as there are no 2 dots on the same line, it is still a function. It just has like predefined start and stop values, so like it will only be at these certain values. For example, this is -4, -3, -2, -1, 1, and let's remove that dot because it wasn't there. 2, 3, 4. Then this function's domain would be equal to x is part of the set, -4, -3, -2 until 1, 2, 3, 4. And similarly, the range would be just every single point individually. Okay, we're on to our final function, and actually our final question for today, quite a fast speedrun, because there weren't too many questions, so it's asking us for a graph that looks like this. Is it a function? This line should be a lot straighter. And the answer is that this is a function because there are no intersections if we draw a straight line. We can draw a straight line anywhere on this graph and it will only ever hit 1 point. So that was a pretty speedy function run. I hope that you now know what the difference is between a relation and a function, and you now know how to identify a function from a graph. So that's all for today actually, and I will see you tomorrow hopefully for the next speedrun on chapter 2. See you then.